Okay, did you manage to complete the tasks that I laid out for you in these questions? And most importantly, the first task. Well, let's have a look at my solutions. So if you remember, the most important thing I asked you to do was to take the phrase "experience is the teacher of all things" and display each letter in the phrase on the microbit screen together with the location in the alphabet corresponding to that letter. So E would be 4, X would be 23, etc. There were a couple of tricks to this. The first was, I already gave you the message in alphabet. You had to set up a for loop because you have to go through every letter in the phrase or character, including the spaces in the phrase "experience is the teacher of all things." So you could go for something, index is what's typically used, from 0 to strictly its length of message -1, but length of message is good enough for this purpose. And they had to loop through every letter, every character in the phrase. This is then the tricky part. You had to combine the character from message at index statement with the find index in alphabet statement. And this is the way to do it. So let's think about the first variable here, letter in message. This is the character from the message at a particular index. So for instance, message is "experience is the teacher of all things." As you loop through index at 0, letter in message is going to be the character from message at 0, which is E. When we go through again, 1, letter from message, in message, is going to be the character from experience and teacher of all things at index 1, so the X. So this is actually the easy part. We've done very similar things before. You're looping through and you're showing the strings that correspond to this index. Now for the new element. What you also had to show was the index in the alphabet. So you had to go to the alphabet and you had to show the index of all of this. So the index of character from message at index. I've written it like this to try and show you how it breaks out into 2 steps. First, you find the letter in the message, EXPER, in the familiar way. And then once you have the letter in the message, you say, give me the index in alphabet. So in alphabet, find the location of the letter in that message. So to go through again slowly, when we're at E, letter in message is going to become the character from message at index 0, which is E. When we're at 0, character from message at index 0 is E. So letter in message is now the letter E. That's part 1. Part 2, in the alphabet, find the index of letter in message. So we're going to go to alphabet and we're looking for the index. And remember, the letter in message first time through is E. So the index is 0, 1, 2, 3, 4. And then we're going to show that. Then the loop will move from 0 to 1. So the index is now 1. What's the character from message at index 1? Index 1, 0, 1 is X. So we're going to display X. And now letter in message is X. So within the alphabet, find the index that corresponds to the letter X. And that index is all the way over here, which is 23. Keep going. You can go for index 2, which would be P, etc., etc. You're going to first of all find the character at the index moving through the message. And then once you know what that character is, you're going to find where in the alphabet the index is that corresponds to that character. It's a little tricky to think about 2 variables like this, but it is an important element of programming to be able to use various variables to build on logic of what you're trying to achieve in your algorithm. So if we've done this right, we should see the letters one by one and the corresponding indexes. So let's try it. E for X is at 23, great. P is at 15, and so on. Now you're going to hit a problem in a second. Once we get to the end of the word experience, we're going to hit a space. So C we're coming up to is index 2 in the alphabet. E is index 4. Oh, there's the space. And did you see it showed -1? And the reason for that is, imagine when we get to the space at the end of experience. We've got to index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in message. So once we're at 10, it says, okay, character from message at 10 is space. So it's going to show the string space correctly. But here it says, find the index in alphabet of space. Where in alphabet is the location of space? And it can't find it because we haven't included a space. We could include a space in the alphabet. And had you done that, this would in fact, in a very clever, simple way, address both of the stretch goals. Because now there is an index that corresponds to space. Space is now the 0th index in alphabet. It's at location 0. And so -1 will no longer be printed to screen. But also, we've shifted everything else along by 1. If space is now 0, A is 1, B is 2, C is 3, D is 4, E is 5, which was with the other request to not 0 index, but to start the alphabet at index 1. So if we go to the microbit and hit play, you'll see now that E corresponds to 5, X corresponds to 24 as requested. And you'll also see when we get to the space at the end of the word experience, that the space has become index 0. We'll know we're close because we'll see C, which is now the 3rd letter correctly in the alphabet. Here it comes. C is 3, E is 5, and the space is index 0. So that's one solution to both of the stretch goals. But more explicitly, if you wanted to think about it as I suggested, using an if, then, if, else loop, if then else loop, then here is a different way to achieve the first stretch goal of not displaying the -1s to screen for the spaces. You simply add a logic statement that says, if the letter in the message is a space, so when we get to a particular index where the character from message at that index is a space, so if we're not equal to that space, do everything we did before. Work out where in the alphabet the letter is, the index corresponding to the location corresponding to the letter, where is it in the alphabet, and show it. However, if we are equal to space in message, then just show the letter. Just show the first part, don't worry about the index. This would have been another way, if you thought of doing it this way, kudos. Another way of not displaying the spaces. Notice, displaying the spaces, but not displaying -1 because it couldn't find the space. So if you've been watching over here, you'll find that spaces just don't come with -1s. No number is displayed. You just see the space. Perhaps the smartest way, and I mention this as a stretch goal because it will be an approach we need for the Caesar cipher. Perhaps the smartest way to achieve the other stretch goal of showing 1 for A and 2 for B and 3 for C, so shifting everything by 1, rather than just putting a space at the start of the message, is as follows. Again, all of this code is very similar to the previous code. We're finding the character from the message at each location as we loop through 0, 1, 2, 3. We're saying if that character is not a space, we're going to do something special and just show the space. But if it is a space, this looks identical to before with one change. We're going to show the string that corresponds to the letter in the message. So we're going to show EXPER. We're going to determine the location in the alphabet where there is that letter in message. So for the E, that will now be 0, 1, 2, 3, 4. But then we're going to use this special statement that I found in the variables drawer called change. We're going to change the index by 1. So how does this work? Well, as we're looping through, if our index is 0, we look up the letter in message. We find it's E. The letter in message isn't a space, so no special behavior. We're going to take the E, we're going to show it on the screen, and then we're going to say, okay, where in alphabet is the E? 0, 1, 2, 3, 4. We want it to display as 5, so we're going to change it by 1 before showing it on the screen. So that's quite involved, but I wanted to build up this whole stretch goal and show you this so you can think about it for a little while, because in the next session, we're going to use this block of code to actually write a Caesar cipher to encode and decipher messages.